Okay, so hello everyone, welcome. Can you hear me? Hello.
Yes, sir. You're audible.
Okay, so basically today is our last number of class for the total 7 days online training program. And mainly today I will try to discuss about that change detection on land use and land cover classification. How you can easily use the Google Earth Engine platform for monitor the change detection, as well as you can also use the ArcMap software for creating the change detection map. Okay, just I simply share my screen, then we will start today's class. So now can you see my screen? Can you see my screen?
Yes, sir.
Okay. Okay, so basically in this time, first of all, I will create the two time period land use land cover classification map, and then try to make the change detection for the different time period. Okay, so in this time, I just work with the Dhaka city boundary area. So first of all, I can simply import it the boundary shapefile. Okay, so this is my region of interest. I simply import my shapefile and put the name such as ROI. Okay, and then in this time I used here the Sentinel-2 satellite imagery, and then try to make this land use land cover classification map for the two time period, and then make the change detection map also in here. So I just simply search here of the dataset Sentinel-2, and I use here the Sentinel-2 surface reflectance. This satellite image I want to use. It's not satellite. Okay. Yeah, this is surface reflectance, SR for surface reflectance. I use these satellite images and then try to make the land use land cover classification map for two time period, and then also make the change detection. Okay, you can simply import, or if you can simply copy this selection snippet and paste in your code editor. Just I simply paste here and then put a variable name, suppose S2. Okay, so I import my region of interest and also import the image collection of the surface reflectance in Sentinel-2 satellite imagery. And now I just simply show my result. So I can simply take a variable. Suppose this variable name is that geometry. And then call my area. Okay, so we can simply show the result. First of all, I simply show my display my layer. So I simply use the map dot add layer, and then simply add a layer ROI and focus the center. Use the map dot center object ROI. Okay, so this is my region. Okay, so in this time, for this region, I just filter the two time period satellite images. Okay, so first of all, I just simply take a variable. Suppose I take the image for the year of 2023. Okay, just I simply for this year. So I simply take a variable. Suppose I filtered. I take the variable name and call my collection as 2. In this time, this image collection I just filtered according to my time period, according to my image properties, all of the things. So first of all, I simply use this filter bounds function. Okay, and put my area. Or if you want, you can also use here the another way. You can simply use here the filter and then how you how we can filter. In this time I want to filter according to the boundary. Just I simply use here the arc engine filter dot bounds. Okay, and then put my shapefile variable name. In this time this is that RY. Okay, and it also okay, there is no problem. And then suppose I also need to filter, I simply use here the filter filter. In this time I want to filter the date, so just I simply use here the art engine filter dot date function. Or if you want, you can simply directly write the filter date function, or you can also write the filter, and then how you can filter, just you can simply put this. Okay, then I simply put here my start date and end date time period in here. Suppose in this time I want to put this time period for year of 2023 1st January from year of 2023 February 10, and then okay, and then I just simply use another, suppose I simply use the filter and use the arc engine filter dot less than, I simply filter the image properties. So image properties, I can simply go to this image information sheet, and here I can get the image properties. I filter according to the cloud pixel percentage. Okay, less than 1% cloud pixel percentage. In this time I have to use, and then I simply paste this argument here, and then simply comma sign and put here the 1. Okay. Okay, so in this time I take only for this images which image is the less than 1% cloud pixel. Okay, and then I simply use the select function. Select. If you want, you can make the list and select your specific band B1, B2, B3. But in this time I want to select all of the band which are available for the Sentinel-2. So for that I just simply use this sign B band, then use here the dot notation, and also use here the start. It means that in this time I select all of the band which are available in the Sentinel-2 satellite imagery. Okay, I select all of the band. Okay. Okay, so in this time if you want to check how many images are available for this time period, you can simply use here the print function. We already discussed about this part. So how can you just simply print and call the filter date and use here the size function and click to run. So now I can get how many images are available for my region between this time period. I can get total 6 images. Okay, so in this time I create the median composite using this total 6 images. Just I simply take the variable, suppose I put the variable name, suppose as a before, and then I just simply call this filtered paste here and use here the median function. So using the total 6 images I want to get the median composite, and this composite also clip with my file is that ROI. Okay, now I display the layer in here. Just I simply use here the map dot layer and then call the before. I want to show this object and click to run. So now it display these satellite images for this time period. Okay, I can get this image look like this. In this time I need to add here the visualization. For that I simply click on here the layer 2 and then set the, suppose I set the true color composite B4, B3 and B2, increase in the stress 98%. And apply. Okay, and then I also just take the import this visualization and simply copy and paste after the object name, and also put this layer name such as I put the. Okay, so in this time I get this satellite images for this time period, year of 2023, this time period. Okay, in this time I also take the another satellite images, then I make the classification and then also make the change detection between the different time period. Okay. Okay, So in this time, first of all, okay, so I'll take the another images, then we also move to the classification. Okay, so for that I simply take the another variable. Suppose I put the variable name is that after. Okay, and then all of the things will be same. Just I simply copy the code from here and simply change the time period. Okay, then we can easily get this. In this time I simply put this time period such as suppose year of 2018 1st January from year of 2018 December 31. Okay, and all of the things will be same. Okay, and finally I can take here such as, in this time I simply use that the directly use the median function. If you want, you can also take the another variable look like this, there is no problem. In this time I use all of the function together, and then I simply use the clip function. Clip with my shapefile is that ROI. Okay, I want to show the result, just I simply use the map.add layer function, add layer, and then call this after and paste here and click the run. So now I can get the another layer. Okay, and then I simply add here this visualization b4, b3 and b2, increasing the state 98%, and then apply. Okay, and also import this and then simply copy and paste after the object name, and also put the layer name after. Okay, so you can see now I can get the 2 time period satellite images. In this time I just simply make the classification using the total 2 time period satellite images, and then make the final change detection map. Okay, so for that we are also apply the same method, which method we already discussed about that. So you need to take the training point for the satellite images. So in this time I simply take the training point and then try to classify the both of satellite images. Okay, so first of all I try to work with the satellite images, so I simply take the training point. Okay, so again you can see this is the Sentinel-2 satellite images, surface reflecting satellite images. So in this time I take the training point from here, so I can simply click on the marker and then simply put here this. You can simply put the training point for suppose first of all urban or build up area or urban or build can use, and then feature collection property I can simply put the property name is the class and set the value for 0 for the urban. Okay, then okay, so in this time I simply take the training point for the urban. Okay, I take the urban and then also take the new layer. In this time I need to take this for such as barren land, and then feature collection property it will be class and set the value for 0 1. Okay, okay, then and you can also use here the different types of band combination for identify the barren land or other types of feature. So in this time I simply take this barren land from here. Okay, then I simply take this another new layer and put here this for water body. Just I simply put the same water body, water feature collection I can simply put here the class and put the value for 0, 1, 2. Okay? And take the training point for the water body. It's just I simply take the training point for the water body. Okay. And then I also take the another layer for the vegetation. And put here the feature collection property. Property will be same for class and set the value 0, 1 to 3. Okay. And then I simply put the take the vegetation. Okay. In this time I also take the training point for the vegetation. I add all of the training point in here. Urban, land and water and vegetation. So in this time I just simply merge all of the training point, then extract all of the pixel value, and then use here the classifier, and finally classify the 2 time period satellite images, and then also make the change detection. Okay. So for that, first of all I need to make the, I can simply take a variable. I need to merge. I simply use here the training, and I merge all of the feature. First of all, urban merge with parent, and it also merge with water, also merge with vegetation. Okay, merge. Okay. After that, I need to extract the pixel value, overlay the point on the image to get the training data. Okay, I extract the pixel value. So for that, I can simply take a variable. Suppose I put the variable name is that, I can use the same variable. There is no problem. Suppose I use a training, and then I call this my image. So I first of all I take the training point of the before. So before this image, I simply copy, and after that I simply paste here, and then use a function sample regions, okay, and put all of the argument one by one. I simply make a dictionary, curly bracket start, and also curly bracket end, and put all of the keyword and key value. So first of all, collection. So collection come from this training. Simply copy and paste here. Then properties. Properties is that our property name, class, scale, the resolution. I can simply put it at the 10 meter resolution. Okay. And then it's not it. I simply remove it. Okay. So now I can see. I can simply print this training and click the run. It's working. Okay. With computing. Okay, so you can see now it is struck all of the pixel value in here for every point. Okay, we can get. So in this time, I just make this classification. So in this time, I want to add here the random forest classifier and train my model. So for that, I can simply make a classifier. First of all, I need to create the classifier. So I simply take a variable. Suppose this variable that classifier. Okay, I put the variable name is the classifier, and then call the ee dot classifier dot file random forest. Okay, this is my classifier. This classifier I want to use and train my model using this dataset. And here I can get all of the argument. I simply make a dictionary. Curly bracket start. Curly bracket in. First of all, feature is that training dataset. In this time it's the training. Just simply copy table name and paste here. Then class property, that our property name. Time it's the class. Input properties is that in this time I have to take the all of the band. Okay, so for that I simply use here the first of all I call the before. Yes, before, and then I simply paste here and use here the band names function. Okay, in this time I add all of the band in here as input properties. Okay, so now I can check. I can simply add all of the band in here, and then it's not needed for this time. I simply remove it. Okay, so you can see I simply create my classifier. Okay, and then I train my model in here. In this time, I just simply make this classification result. So for that, I can simply add this classifier with my image. So just I simply take a variable and put the variable name is that before classify. Okay, I use here the before image. Okay, and we have also another image after. We can use this classifier, same classifier we can use in here. So in this time, I just simply call this before image. You can see I already create the before image. Simply copy and paste here, and then use a function. This function called the classify function. Mainly this function connect our classifier with our image. So I simply copy the classifier and paste here, and then finally I can show the result. Map dot add layer, and then call the before classifier and paste here. Okay, and then I can simply use here the visualization, different types of classes. I use here the mean. It will be start from the 1. Sorry, it will start from the 0 and max up to 3. And I also use here the plated function for different type of color. Suppose I want to show the result for that. Suppose R1 I want to show the result as a red color. Then parallel I want to show the result as a suppose brown color. Then water I want to show as a blue color. And finally vegetation I want to show as a green color. Okay, and then I also put this layer name such as before classify, and then click run. So now it created the one classified image. Okay, so you also need to add here the decision tree value. I simply put here the 50 and click the run. So now it also classified the before satellite images for the year of 2000 2023, this time period. Okay, I think I also use at the for the barren land I can use at the yellow color, then it also better understand. So I simply use at the yellow. Okay, now it's okay. We can get this classified image in here. Classified, the red color is identify the build up and or barren land, and yellow color is identify the barren land, water is the blue, and green is identify the vegetation. Okay, so now you can easily calculate it, the area. You can also make the for your accuracy assessment, all of the things you already covered. So in this time I will not showing this part. So in this time I also classified the another image, then try to show you that how you can easily make the change detection between the two time period images. Okay, so for that in this time I also need to classify the other image, so which I already created, you can see. So in this time for the before, you can see I use this image and classified this image. Okay, in this time I use this after image and classified this after classified. This image in this time I just use this image and classified the another classification map. Okay, use the same classifier. For that I can simply use this. So same way I can use in here, same classifier, same, all of the things will be same. I just simply connect this classifier with my image, and in this time I also use here the same training point. Okay, for this classifiers also. But if you want, you can also take the training point for this satellite images, new satellite images, and also run your model. There is no problem. Okay, so in this time I use the same classifier and then try to make this classification also. For that I can simply classify. In this time I just classify image. So for that I just simply take a variable. Suppose this variable name is that after classify. In this time I use that the after image. Okay, so for that I simply call this after image, you can see, which I already created in here, and then paste. Okay, and then I just simply connect with my classifier. So I use a classify function and call my classifier is that classifier. Just simply copy and then paste here. Okay, okay, now I can simply show the result. So I simply copy the same line of code from here and paste, then simply call the object name and paste here, and also change the layer name. It is the after classify, after class, and click to run. So in this time you can see I can get the two time period classified image in here. And now I want to just show you that how you can easily make the change detection for the two time period, and also calculate it the transition area, how much area will be converted into the build up area, how much area will be converted into the barren land or vegetation. So all of the transition area we also try to calculate it in this time. Okay, okay, so we can get the some wrong classified images in this time in here. Okay, okay, so I think it also better you can also take the training point from this after satellite images and then try to make this classification again, then we can get the better. Okay, so in this time you can see it showing the result look like this. Okay, so okay, okay, so I try to change this. Okay, so in this time I also take the training point again and then make the classifier again. So for that I can simply open the after this classified image and then take the training point again. So I can simply click on the new layer. Okay, and put here this as urban, suppose after, just I use the urban after, and feature collection use the same as class and set the value for the 0. Okay, then I simply take this urban area as a training point for the urban area. I take. Okay, then I also take this new layer and put here this parallel. That's as after. Then put here the feature collection, put enable class, and take the value 0, 1, and okay. Okay, then I simply take this. So I simply take this training point for the barrel end from the after image. Okay, and also take the for water. So I use the new layer and put this layer name such as water after. Okay, and then feature collection property will be class and set the value for 0, 1, 2. Just I simply take the training point for the water body. Then I simply take this hesitation just after, and then feature collection property will be class and set the value for 3. Okay, and take the training point for the vegetation. Okay, so now I just simply use this. So I use the same code, just I simply copy. I use the copy from here and paste it. In this time I simply change the name, suppose training, and also change this, merge all of the feature name. First of all, urban, after barren land, water station. Okay, and then all of the things I want to use, and then I can simply also change this, suppose after training after. I sample this all of the things, I simply copy this same and use here this training after, and then all of the things will be same, and then finally I simply print this, copy and paste. Then I simply use here this, I just use here this training after and all of the when I use, and okay, now I want to show the result. In this time These are the classifier. Okay. In this time, this classifier I want to add with my image after image. So for that, I can simply call this. So I simply use the same and paste here, and then use here the before. I simply use here the after classify. Okay, then simply call this. I simply call this classifier and paste here, and then also call this after image. So you can see I already done the after image in here. Okay, after image, you can simply copy this image from here and then paste. Okay, so now I just try to add the layer. I use the same code for that. I simply copy and paste it, paste it. And then use the after classified object name here, and also change the layer name such as after classified, and click the run. Now you can check what's the result we can get. Okay, so it also showing a lot of water body in here also. Okay, I use a null, right? In but it's showing a lot of water body in here. Just a minute. What's the problem? Okay, again. By simply decreasing the and also increasing the training point for the R1. Okay, then try to run again. Okay, what is the problem in here? Okay, just I simply change the time period. and try again. With problem for the after image. Before image is the clear, but in the after image, okay, so just I simply use this 20. Okay, so red is identified blue. Okay, so now you can check the result. Okay, so it's showing a lot of water body in here. Okay, but we can easily solve the problem by using the also add here the some external bands such as NDVI or NDWI or other things we can easily add, and then we can easily solve the problem. Okay, for the I think it will be happened because in this time we are only using the internal band which are available for the Sentinel 2, but for this in this time we can get the lot of water body in here. Okay, so that's why for developing this land use land cover classification for this time we also need to add here the some also external band such as NDVI, NDWI, EVI. Then I hope it will be not happened again. Okay, so that's why it takes the some problem. Okay. Okay, so in this time, we can just change our ROI and then try to work for the another satellite images. So here I already write the code for this region using the Sentinel Landsat 8 imagery and also classified this image. So in this time I try to show you all of the things from here and try to make the change detection map in here. Okay, so here you can see all of the code we already write in here. So in this time we already classified these satellite images, you can see, for the different time period for land use 1991, 2001, 2011 and 2021. So in this time I just try to show you this part for this change detection between LULC of 1991 and 2021, how we can easily do for the two time period satellite images and make the change detection map, and also calculated the change detection area or change transition area between these two time period. Okay, so let's go. So first of all, we complete the classification. All of the things will be same process. You can take the training point, you can make the training data set and also use the classifier. All of the things will be same. Okay, in this time we can just use this two classified image, LULC 2021 and 1991. Okay, so after and before we can get the two satellite classified images in here. So in this time we can just simply make this change detection and also calculated the change detection area between these two time period. Okay, So for that I just simply reclassify. Okay, so in this time you can see I can get that I can use that this value, it will be 0. Okay, it will be value 0, and last value you can see for the parent land we can use that the 4. Okay, so 0 to 4 I can separate all of the class from 0 to 4. So in this time I just reclassify from 1 to 4. Okay, so I ignored the 0. So in this time I also write the new code in here for the change detection. Okay, so here I can use the value 0 from 4. Okay, in this time I need to reclassify this value and make it 1 to 5. Okay, so here I already classified LULC 1991 and 2021. In this time I just reclassify this value. So in this time you can see water is 0, forest is 1, then build up is 2, then 3, then 4 and 5. But in this time I want to use here the water is 1, forest 2, then 3, then 4 and 5. So 1 to 5 in this time I have to reclassify for both of classified image LULC 2021 and LULC 1991. Okay, so for that I need to reclassify for change detection. Okay, so you also make the reclassify. So I can simply take a variable. Suppose I put the variable name such as before class. Before classes. Okay, then I simply call the before classes classified variable name. So in this time you can see before and after. This is the after and this is the before 2021. So this classified image is already stored in variable. So just I simply find out the variable name. Okay, so this variable name is that classified image 1991. Okay, sorry, before is the 2021. Okay, so just I simply call the classified image 2021, simply copy that, copy and paste here and paste here. Okay, and use a function, it's called the remap function. So use the remap for I need to reclassify from 0 to 4 turn into 1 to 5. Okay, and then I simply use here the value for SSS. I make a list for 0 1 2 3 4. Okay, all of the value in this time turn into look like this 1 2 3 4 and 5. Okay, so I reclassify for the before class or in this time classified image for 2021. Same process I also apply. I take a variable and put here the after classes and call this after class means that 1991 this satellite image this classified variable name I call. So I simply go to this above and then try to find out this variable name in here. Here you can see okay, classified image for 1991. Click copy and paste here. Okay, and use the same way remap function and also reclassify from 0 to 4 turn into 1 to 5. Okay, that's a reclassify. Okay, so in this time I need to show the change detection, show all change areas. So in this time I want to show all change areas. So for that I write the comment show all change area between this time period. Okay, so for that I just simply take a variable, suppose change, and after that In the changed, I simply call this after classes and use here the subtract function with before class. Okay. And then use here to equal to. In this time, I want to show the result only for the changed and unchanged area between this time period. Suppose 1991, here I can get the water, but in this present time 2021 I also get the same water. So there is the no changed between this time period. Okay, so in this time I can get overall all of the classes change. Suppose which changed, it's showing the another color, and which is not changed, it's showing the another color. Okay, so for that I simply use here the map dot add layer and then call the changed and paste here. Okay, I want to show the result. So mean 0 and max up to 1. Okay, and also add here the plated function, plated, and make the list like this. Suppose they are the white color and also they are the red color, and also put their name as change. So now we can get between this time period where is it changed or not. Two types of classified result we can get. It working? Okay. In this time, you can see how I can get the two types of classified result, red and white. Okay, so in this time, where there is the no change, we can get as a white color, and where is the change, we can get the red color. Red color, it means that it will be changed. Suppose in this time, it can be water, any change. Okay, overall change we can get, overall change map. Okay, it can be water to build up area or build up to water, or it can be forest to barren land or barren land to forest, I don't know. But in this time, this map showing the overall change between these two time period. So you are up to 1991 to 2021, which I want to add in here. Okay, so it's all the overall change. So red area is identified, there is the change, and white area is identified, there is the no change. Suppose this white area in 1991 there is the water, and 2021 we can also get the water, so there is the no change. Okay, so we can easily classify the two time period where it changed or not changed. In this time, I just need to calculate all of the transition area. Suppose how many water body turn into build up area in year of 2021, how many vegetation turn into build up area in 2021. So this type of transition zone I need to calculate it. Okay, so for that I just simply write the some code. Okay, so anyone any question in this time, you can ask me any question or any doubt for this remap function or overall change.
Sir,
Yeah, please.
sir, when you write 1991, that means 1991 year, you basically write after, and 2021 you basically write before. But when we basically try to see the change from 1991 to 2022. So 1991 basically before, and to 2021 is basically after.
Oh,
This is the confusion.
okay, just let me check it again. Okay, so in this time you can see 2021 and 1991. So in this time it is the after. So 1991 it is the after classified image. After means that it will be past. Okay, and then 2021 we can get this before. Okay, so it is a future, then it's not past. Okay, so after class is that past image, and before is that class is that 2021. Okay, any doubt on any question?
Yes, sir, not properly clear, sir.
Okay, so after, so 1991 it is the after or past, and then we need to classify it for the before class 2021. So such as also you can see here I write the code. When I can write the code, you can see 2023 this time I make it the before. Okay, and after I can use here this the past time 2020 to 2020. Okay, so this is the after and this is the before. So after means that past image, which this is the past, and before is that after past. Okay, so it is the after past.
Okay, sir.
Okay, so in this time we can see we can get the overall changes between these two time period. In this time I just need to calculate the transition zone between this how much area will be converted into the different time period. So in this time we can calculate area look like this way. Suppose 1991, suppose water in 1991 how much water turn into urban in 2021. So 1991 is the after and 2021 is the before. Okay, so in this time we can reclassify this 0 to 4 and 1 to 5, because in this time we can calculate the area or transition zone. Okay, so here you can see I write the code. Suppose 102, suppose this is the 102, it means that 1 is that after class and 2 is the before class. So what is the 1, suppose in 1 is the 1991 here I can get the number 1 class. 1 is that in this time 1 is that water. Okay, but in 2021 convert it class 2. Class 2 is that you can see 01 forest. Okay, so 102 it means that class 1991 it will be water, but in 2021 it convert into the forest. Such as 302, it means that 3, what is the 3 you can see, 1 2 3 is the build up area. Build up area in 1991 build up area turn into class 2 forest. Okay, so in this time mainly when you can calculate the change detection, we can get the result look like this. Suppose 102 302 then 401 302, it means that it is the after class or past class and it is the before class. Okay, so suppose after class is that 1991 and before class is the 2021. Suppose 1991 I can get the forest. How much forest will be converted into the build up area in 2021? Okay, so this type of result we can get from here. It's called the transition zone area. Calculate the transition zone area. So in this time I just simply calculated the area. So for that I can simply suppose I can simply take a variable, suppose March, and then call the before classes. These before classes multiply with 100, then I just simply use here the add function, add with after classes. Okay, and I can simply put this rename function, rename it as a transition. In this time, when I want to just print this, what the result I can get, you can see. I simply print this merge. Click the run. It working. Okay. So okay. So I think some networking issue, so that's why it takes some time. Okay. Okay. In this time, this transition, I need to calculate it, the frequency histogram. I need to calculate the pixel for each class. How much pixel will be transition from different two time period. Okay. So for that, I need to use a function frequency histogram. So use a frequency histogram to get a pixel count per class. Okay. So for that, I can simply use a function such as I take the variable. Suppose this variable name is that transition matrix. Can use any name. Then I can simply call this merge and paste here and use a function. It's called the reduce region function because I want to calculate it the pixel count per class. Okay, then put all of the argument one by one. I make a dictionary in here and also make value. So then first of all, reducer. I want to calculate it the reducer such as e dot user dot frequency histogram okay, frequency histogram, and then geometry. We're using here the same, and then scale is the resolution. I simply dance it for the 30-meter resolution. Then I simply normally expand for this. Then I can simply use here this. I can simply print this transition matrix and paste here. Okay, and I want to get it from transition. Copy the name and paste here, and click run. So now we can calculate the result, the print number of pixel for each class transition. Now it print, you can see. So it's computing. Okay, so it's showing the 0. Why? So I simply call the merge and reduce region function. Okay, just I simply write the function again. Merge and use at the use region. All of the argument. First of all, reducer dictionary. That dot reducer dot ram. It is that guys check the geometry or shapefile variable name. Shapefile variable name is that okay. Shapefile variable name is the AY. Okay, sorry for that. I use at the geometry, but it will be AOY for this my boundary area variable name. Okay, just I simply use at the AOY geometry, and then scale is the resolution at 30 meter. But need as a big region, I can simply use at the max pixel. Okay, now click to the run. Okay, so it takes a lot of time. Okay, so here you can see now you can get the result. In this time, this result represented the number of pixel for each class transition. Okay, so here you can see I can get the look like this: 101, 102, 103, 104, or 105. 101, what is means? 101 means that you can see 1 is that water. Suppose how many water body suppose turn into water in 2021, and this one is for 1981. How many water body will be turned into, suppose 102. Suppose I can simply write this 102. It means that urban to air. 103 means that urban to water. Okay, so here you can see, suppose 101 it means then water to water. 102 it means that you can see water to forest. 103 it means that water to build up area. 104 it means that water to agriculture. 105 it means that water to barren land. Okay, so we can get all of the pixel for each class transition. So now if you want to calculate the area of each class for the transition, we can use here the group reducer, and then we can easily calculate the area. So in this time it's showing the pixel value of transition area, pixel value. In this time, from this pixel value we can just calculate the area. Suppose water to water, water to urban, water to built up area. So this type of all of the classified area we can easily calculate it in Google Earth Engine platform for the transition area. Okay, so for that, in this time you can say I can get the result 102, 202, 203. I can get the result like this because you can say before class multiply with 100 and add after class. Okay, for this calculation I can get the result look like this: 101, 102, 103, 104. Okay, so I can get this result look like this. In this time I just simply calculate the area, all of the it's showing the pixel value. Okay, so now the number of pixel value for each classes for the transition. In this time I calculated the area, all of the transition area. So for that, okay, for that I simply use a variable. Suppose variable name is the area image. In this area image I just simply call the ee dot image dot pixel area. So basically we can get the result in square meter, but in this time I want to need the result in square kilometers. So that's why I simply use the divide with 1,000,016. Okay, sorry, 1 is 1. Okay. After that I can simply use a add band function, add bands with merge. So this copy paste here. Okay, so now I can simply use the group reducer and calculated the area, all of the